Good evening. This is Hemalata for Data Analytics Video Lecture 7. What is data stream model? Computers are implementing query operations or computations. Normally these things are done on a data set of very massive size nowadays. This cannot be fit into a single computer, or technically speaking polynomial runtime. So we are following a data stream model. Here a streaming algorithm can access the data in a single pass and only one piece at a time. Not the entire data is getting accessed. Therefore, at any moment, the computer can only have access to its own memory and a single piece of input data. And this is the block diagram for a data stream model. This is a ever entering or ever growing data set. It keeps on coming in. A computer at any point of time will be focusing only on a part of the entire data. Once this is over, it will go to the next part. So that's the meaning of this array. So two factors of considerations are time and the amount of main memory. So what is the need of the hour? Day by day data is increasing in terms of variety, velocity and volume. So there comes the big data. And to analyze this big data, one has to collect the data, store it in a safe place, clean it, perform analysis. And the major problem which is faced by the people working on big data, they are called as big data engineers, they are dealing with unuseful or redundant data. A lot of time and memory is used to store, analyze this extra data. Actually, this data is redundant data, which turns out to be fruitless at the end. So, the removal of duplicate data becomes extremely essential. So what is a conventional algorithm? Initially, how it was accessed? Initially, if my stream is a code, like assume we have an array of data, for example, 20 with 8 unique elements, then we'll be using a brute force approach. So we have to find the number of unique elements in that array. So what we'll do, we'll take each element into consideration at a time. So I'll have another array. Example, if I name it as st unique, okay, stream unique, and it is only 5 unique elements. So initially my new array, this unique array will have nothing in it, so its length is 0, and the first element is not in it. Okay, so the first element which is considered to be unique, as it does not exist in the new array, from the original array, and that is made a copy of it and inserted into this unique array. And all the elements are checked one by one, and if they are already present in the new array, they are not considered to be unique, so they are ignored. And if they are unique, a copy of that element is inserted into the new array, which is called as st unique. This is the usual conventional algorithm which can be adapted for achieving this task. So what is the performance of this algorithm? So running this brute force algorithm for our array, brute force algorithm is a step-by-step basic algorithm. It's called as brute force algorithm. So we'll get 8 elements in this array, and if each element is going to take 20 bytes, then the new array should have 20 into 8, 160 bytes of memory to run this algorithm. So this is brute force is not that efficient for big data. So we find that we'll be seeing two techniques. One is randomized algorithm, and second one is our FM algorithm, which is based on hashing technique. Thank you.